presentation on a 6-month comparison of saltwater electrofishing sampling to traditional seine sampling in saltwater areas of Barataria Bay. Chris Schieble.
Thank you, Mr. Chair, and good morning, members of the commission. I feel like more times than not, we come to you with bad news and ask you to make difficult decisions. So today I'm bringing you some positive news, and I'm kind of excited that we get to show you the latest data, if it's only 6 months, but also what we've been doing here. Okay, so a little bit of history to start out with. I'll be brief, but I'll move through this just to set the baseline for why this is very important. So for the past 40 years, going back to 1985, our department's been pulling a 50-foot beach seine to sample young of the year and juvenile species in the marsh. But as you can see by those pictures on the right side of the screen there, our marsh has been beat up pretty bad by repeated multiple hurricanes over a short period of time. And it tends to shear off the marsh and leave kind of like a cliff-like edge just underneath the water. And the seine is becoming less and less effective over time in its ability to capture those species as well as that size class of fish. So we sought to find better ways to fill those data gaps. So going back to 2016, it's kind of the history and how this all started. Jason Adrians and I wrote a grant for funding from U.S. Fish and Wildlife Service to study salt marsh top minnows. And there's a private NGO that petitioned for salt marsh top minnows to be listed as an endangered species. The salt marsh top minnow is a type of killifish. It's similar to like a cockahoe that you're familiar with for fishing, just a little bit smaller. But 90% of its endemic native range is within the state of Louisiana. It ranges into Texas and just on the edge of Florida and Alabama. But 90% of its home range is within the state of Louisiana. So we understood the concern, but we also tried to find a better method to be able to sample that species. And we decided to try to use some electrofishing. So electrofishing has been around for many years, probably multiple decades, in inland fisheries sampling in fresh water. Our inland fisheries staff have used this model, Smith Root 9.0 GPP electrofisher, for many years. And we modified one of our net boats in marine fisheries to have a safety railing and used this electrofishing unit to sample in the estuary in Barataria. So if you think back to 2016 through 2018, we had high river events, a lot of flooding, spillway openings. The salinities at that time were a lot lower than they are currently today. However, that unit largely loses its effectiveness above salinities of around 19 parts per thousand. Full seawater, for reference, is about 35 parts per thousand. Also, this electrofisher is no longer in production, so we're not able to purchase any more of this unit. So we established a population density model for salt marsh top minnows for the U.S. Fish and Wildlife Service, and the results of doing that sampling from 2016 to 2018 actually resulted in the salt marsh top minnow not being listed under the Endangered Species Act. The U.S. Fish and Wildlife Service used our data, and the petition was withdrawn. So some positive news for once there. Also, we started sampling side by side with our seine stations beginning in 2018 through 2023 for Coastal Protection and Restoration Authority. They have some sampling that they call a SWAMP. It's an acronym for different areas of Barataria Bay and also east of the river in the Pontchartrain Basin. So we sampled multiple seine stations at the same time with the electrofishing gear and the seine sampling gear to see if there was a difference between those two types of gear side by side. And the table at the bottom shows when you compare the seine catch rates over that time period from 2018 to 2023, the electrofishing samples had substantial increases in catch rates for all those stock assessment species listed there, with the exception of black drum and Gulf menhaden at that time. So I highlighted red drum and spotted sea trout and southern flounder. So the first red drum, you can see the catch effort for the 50-foot seine was about 3.32 catch per unit effort, where the Electrofisher was 14.70. And that's a difference of about 342% increase for the Electrofisher over the seine sampling. Spotted sea trout was a 633% increase, and flounder was 1,683% increase in catch effort from the Electrofisher over the seine sampling. So shortly after we completed the sampling for CPRA, that ended with that former Electrofisher, but we became aware of some new technology from a company called Midwest Lake. They produce an Electrofisher unit called the Infinity. Was the first of its kind for sure in the United States, possibly the world, that could actually electrofish in full seawater. We got the opportunity to go test a prototype back in 2023 over in Lake Charles. At the time, Calcasieu Lake was full salinity. It was a drought year, high salinities, and we had full 35 parts per thousand seawater in Calcasieu Lake at the time. And we sampled with the Electrofisher at the same locations that seine samples were pulled. And we wanted to see if there was a difference in species abundance as well as the species richness at each of those stations compared to the seines, just to test out if this actually was going to do what we thought it would do. So we wanted to be able to fill data gaps with relation to our juvenile and young of the year stock assessment species, to develop a statewide young of the year and juvenile indices of abundance for those stock assessment species. And it would also inform recruitment and year class strength for our stock assessments where we're missing that information. So lo and behold, some of the samples, it was very simple test, but it did show a big significant difference in the catch per unit effort for those stock assessment species, as well as a significantly higher overall abundance or biomass compared to the seine samples at those same stations. And you can see some photos here show a spotted sea trout juvenile on the left, as well as a red drum, young of the year, and a juvenile in the middle picture there. So two different cohorts. And then most interesting, the last picture are menhaden, but the samples actually pulled up multiple size cohorts of menhaden at the same time, which typically our seine samples don't get. They either get one size class or another at a typical point in time, but not multiples at the same time. So this year, the first production model of the Midwest Lake Infinity Electrofisher was delivered to the department in July. And we began sampling 16 of our established seine stations that we have in the Barataria Basin only, beginning in July for the past 6 months up till now, to see how this benchmarks to the seine stations that we're currently sampling at the same time. And for illustrative purposes, there's a couple pictures on the right there show young of the year spotted sea trout laying on the measuring board, as well as the bottom picture is a juvenile from this year's spawn class. So that was probably a fish that was spawned sometime in April or May, but you can see it's barely over an inch long. So it's picking up all range of sizes of these species as well as the numbers. And what I'd like to point out is the sampling methodology. So we go to a seine site with this boat. We sample 3 90-second pulses. So the Electrofisher's on for 90 seconds. It's turned off. That's a sample. And then we do another 90 and then another 90. So it's a replicate sampling design. Gives us 3 samples for a site that are collectively averaged together, but it's a repeated measures design. So that picture on the right side up there with those spotted sea trout, that's one sample from 90 seconds. There's that many sea trout coming up in a 90-second sample, which is remarkable. So the pilot study that we're conducting this year, this is the first 6 months of results, but it will go for a full 12 months, and then the boat will move to a different basin, and then we'll benchmark that basin against the seine samples in that basin to come up with that same factor that we're doing in Barataria right now. So the idea is to monitor the relative abundance and distribution of the young of the year and juvenile life stages of those important stock assessment species that you all see and approve the stock assessments this past year. So spotted sea trout, red drum, sheepshead, striped mullet, and southern flounder. You did the last three this year. And we're developing indices of relative abundance for use in those stock assessments, but also we want to develop a statewide standardized quantitative fishery independent electrofishing survey methodology to replace the seine survey ultimately across the state. But in order to do that, we need to benchmark the electrofisher against those seines in each basin in order to see, is it actually doing what we think it's going to do? If we can establish a baseline for young of the year juvenile relative abundance estimates for those stock assessment species, as well as a time series of the indices of relative abundance for young of the year juvenile finfish, those can be used in the stock assessment. So here's a quick map of the 16 stations that we are sampling with the electrofisher as well as the seines. So the seines are done basin-wide every month, and then we go to the same locations with the electrofisher and conduct that repeated measures sampling design of those 3 90-second samples that are averaged together. You can see on the right-hand side is a picture of the vessel in operation, and I threw a picture of what I thought was one of the most unique fish we've sampled so far this year. That's a young of the year triple tail, and it was sampled in the marsh. You don't typically see triple tail up in the marsh, and we really haven't picked up those with the seine at all. And you can see by the size, you're looking at a less than 6-inch long triple tail. But it samples pretty much everything. Everything that's in the marsh, you actually can see with this technology. It's remarkable. So I've got some data here, and I realized that the table on the left is hard to see, and it's not meant for you to see it, but it's to give you the dramatic picture that this technology has actually sampled 86 species to date. So the table on the right-hand side here, or column on the right-hand side of the left slide, is the electrofishing species count, and the left side of this is the seine species count, which has only sampled 77 species to date. Now, the reason I put this up here is because there's some folks that believe, well, electrofishing is biased to the size of the fish. So some electrofishing units may sample a size bias of large fish only and not actually sample the smaller species, or vice versa. It may sample the smaller species and miss the larger species. And I can say that that's not the case with this. This samples everything from juvenile spotted sea trout under 1 inch long to anchovies, silver sides, all the way through the typical stock assessment species that we're concerned about here. So looking over at the right-hand table, you can see that spotted sea trout, they're the 9th most abundant species that we've sampled so far in the past 6 months, compared to 28th most abundant in the seines, which is all the way down here. Also, red drum, the 11th most abundant species in the electrofisher, and they're not even on the table I have here because they're 37th most abundant in the seine samples. Sheepshead are 13th most abundant with the electrofisher, and they're 50th most abundant with the seine samples. Flounder, all the way down here, is the 24th most abundant fish we sample out of those 86 species with the electrofisher, and we sampled none with the seine so far, 0 in the past 6 months. So this is a similar table to what I showed you earlier for the historical data. This is a percent change comparison of the catch effort between the seines and the electrofisher over the past 6 months. So spotted sea trout catch effort for the seine is about 0.28 CPUE per haul, where the electrofisher is 4.28. So that equals 1,422% change of the electrofisher over the seines in species abundance. Red drum, 0.11. Electrofisher is 2.61. That's a 2,182% change with the electrofisher over the seines. Sheepshead, 0.04. 1.35 with the electrofisher, 3,150%. I told you flounder, we didn't catch any, so there's a big 0 over here with the seines, but the catch effort is 0.57. It doesn't give you the percent change because you'd have to divide by 0, and that doesn't work. And in black drum, 0.08 and 0.35, and it's a 325% increase with the electrofisher. But I put a few pictures down here because I wanted to point out, especially on the left-hand side here, one of the other benefits of the electrofisher that I didn't realize until we actually started doing this is that the majority of the fish that we sample, because we're only sampling for 90 seconds, they go in a tub of water on the boat, then they're measured and weighed on the boat. If they're big enough to be able to be weighed on the boat, they're released alive. So I would say, I estimate, I don't have any numbers on this, but about 70% of what we're sampling out there is going back in the water. So all these little guys, these trout here, that typically, had we caught them in the seine, they'd have baked in the sun or been balled up in the mud up in the marsh until we were able to pick them all out of all that stuff. They wouldn't have made it. These are all surviving. So they're going back in the water for you all to catch a year from now. So here's some data on size bins, because I wanted to emphasize the point that I made earlier about how some folks think electrofishing is size biased, and it's not. And here's a good example of spotted sea trout size groups. So down here on the y-axis, this is 0, 1, 2, 3, 4. These are inch groups. So 0 is any fish that's under an inch, of course, and then up to 1 inch, up to 2 inch, up to 3 inches. And then the bars are the percent of the total catch in each of those size groups, right? And then I circled these are your slot sizes. So 13-inch minimum for the trout and the 20-inch with 2 over. What I find most interesting about this is that you look at the electrofishing, those are the orange bars, you get a really nice bell-shaped curve on the size comps that are coming out of the electrofisher, where with the seine samples, there are high spiky data that's missing with large data gaps in certain sizes in here. So you have a more representative sample with the electrofisher than you do with the seines across those size groups, which is important for fisheries management because it allows us to be able to track those age classes over time. If we can look at steady monthly sampling over 12 months and track those age classes, we can track them in multiple years until they get to this slot fishery size and enter the fishery. And a couple examples over here. So this is a good size range of trout. We catch that size as well as that size, and these are juvenile trout from this year that were spawned. Sheep's head is kind of interesting as well. Jason would tell you that this somewhat mimics what you see with the gillnet indices, where we've got a bimodal distribution on size groups that are coming through with sheep's head, where it's very broken and spiky from the seine samples as well. So it does not give us a good representative sample. Black drum size groups, I've probably seen more juvenile and young of the year black drum with the electrofish than I've ever seen with the seines. So it does a really good job of identifying those for us. And you can see again, you've got a nice bell-shaped pattern here to the distribution of the size groups for the electrofisher versus the seines as well. Red drum size groups, this is very interesting because again, you get a bell-shaped curve here all the way out to basically 32-inch redfish. So anywhere from this size to this is one that was spawned this year. And it's just under 3 inches in total length. It would have been probably spawned within a month to a month and a half prior to us sampling that. So we're able to track a fish this size through next year when it becomes this size, and then ultimately here at about 2.5 to 3 years old. This gap is interesting because it doesn't mean that we're not sampling them. It has to do with when we started. So we started sampling in July and we finished up with this data in January. Most of the redfish that we started sampling were around this size range by July already. We will fill this gap as we sample through the winter and into the spring because redfish were spawned from August through October. So you'll start to see these size groups get filled in with data over the next few months. It's not because we're not sampling them. And last but not least, flounder. I like to point out there's no blue bars because we didn't catch any with the seines over for 6 months. However, we got a pretty good distribution in size range on flounder as well as total number over those 6 months. And some pictures here to show different sizes, all from 1/92nd sample right there, are those three, which I find is really interesting. And it wasn't that they were just lumped up in certain spaces. We sampled flounder over the entire estuary. So what are the benefits of all this? So ultimately, it's for proactive fisheries management versus reactive. Typically, fisheries management, based on the current limitations of data sets, is very reactive, as you probably remember seeing these two graphs down here. So this is the spawning stock biomass for female spotted sea trout. And you remember we had to change regulations in order to correct this curve and try to get it above limit for sure and above target before you see the next assessment in 2027. But if you notice, this is done over 5-year periods, right? So we work in these 5-year increments. We don't know exactly what's happening in between those 5-year periods to be able to adjust this at an earlier time. The hope here would be that we would get data throughout that 5-year period for those juvenile indices of abundance to perhaps recommend some changes to you all in a more timely basis instead of every 5 years. And those changes could be less draconian than having to have massive bag limit changes or massive size changes to maybe correct some of this and get things back closer to target before they get this far below the limit. Also, this is the winter kill index that you saw this past year after the freeze we had last January, a year ago. We hope to be able to better track the impacts of events like this with the electrofisher because we'll know how it impacted that cohort or that year class of spotted sea trout or red drum or any of those species as we go into the next year instead of having to wait for an assessment to do that. Some other expected benefits. We really have no other methodology or sampling technique to sample living shorelines that are being put in or riprap like this that the coastal restoration projects seem to be moving towards that type of habitat. I couldn't tell you what colonizes that habitat when it goes in or the benefits of those habitats to fisheries, with the exception of this boat, because it can sample along the edge of all that and pull all the fish out of it. I wanted to show you that Jason Adriance wears more than a bow tie. Sometimes he wears a PFD, but if he were standing up here, he would tell you that, of course, there's some caveats with this. So the first caveat is that this data I'm showing you, it's remarkable, but it's only within the Barataria Basin, and it's only the first 6 months. I don't expect we're going to see any drop off. I think things will actually get better over the next 6 months as we finish the Barataria Basin, but we need to do this across all of our basins statewide to benchmark this with the seines, as I mentioned before. And then the hope would be that ultimately we replace all those seine samples with electrofishers statewide, move in that direction, and then get really good data for at least a couple of years to where we can establish that baseline. So what is that baseline? If you could literally get the electrofisher to use all 280,000 watts of power and get up to 88 miles per hour and go back to 1985, 40 years ago, what would the samples look like? Would they be similar to what you see in these two bins here, which are from the two dippers on a sample, or would it be twice the catch effort back in 1985 that we have right now, or 3 times that catch effort? We don't know. We can't benchmark the electrofisher against itself back when we started seine sampling. So we have 40 years of seine data, but we don't have 40 years of electrofishing data. So at some point we have to have a hard start in the time series to move forward from. Unfortunately, we just can't go backwards. And bear with me, finally, I'd like to thank a few folks here. So first off, the biologists in coastal study areas 1 and 3 for their assistance and hard work over the past 6 months, in addition to their regular assigned duties on top of those duties. None of this would have been possible without Matt Duplessis, Jonathan Winslow, and Sean Kinney in Inland Fisheries for their knowledge, technical expertise, insight, and willingness to go above and beyond to help. Peyton Cagle, Christian Winslow, and Patrick Banks for their constant help with logistics and maintenance coordination on the vessel. Joe West, Eric Lang, and the stock assessment team in the back. I like to call it the Skunk Works. Their help with data analysis and scientific sampling rigor to set up this design from the beginning to make sure we get it right. William Hanno, especially for his tremendous help in daily operations, field expertise, troubleshooting, and data review. Jason Adriance in the back for his project oversight, hard work in the field, and valuable scientific input since the start of this project, and even before, back through 2016. This wouldn't have been possible without him. Chad Corville for his continued support of this project, and Quest for Better Scientific Data in Fisheries Management, Brad Trasher in the back, and CCA Louisiana for their overwhelming support of this project and the need for better data. And finally, I'd like to end with Assistant Secretary Montague and Secretary Bosworth for their wholehearted support of this from the initial project launch through now. And of course, Governor Landry, because of his support and dedication to better data to feed into better science and pushing this department to do a better job. I think it's well deserved for his thanks as well. So if you have any questions about this, I'd be glad to answer them.